Nice. Testing. Testing audio. Testing. 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 Woo! All right, welcome to the first live stream. Let's start cranking out some PCBs. So I'm going to be checking out this. Let me know if there's any issues with the audio and stuff. This is my first time live streaming, so let's try and put on a good show. All right, so we've got a stencil here that I'm going to use to make these PCBs. And I've got a little hot plate that's basically going to cook these things and heat them up to a point where the solder will melt and it'll join the components to the board. I'm realizing I need some kind of thing to grab these because it's going to be hot and I can't just be picking them up off of here when they're up to temperature. So I'm going to get some pliers or something. This will have to do. Cool, so I'll be keeping an eye on the chat, and if you have any questions or anything about what I'm doing or how the project is going or future projects, just let me know. And let's get started. So this is my first time using surface mount PCBs, using this method of putting solder on the board. Alright, welcome everyone. Beyond Belief, Mo Reefs, Carlos, Alonzo. Let's get to it. Okay, so basically how this works is I have to line this up and get you a better view here. I have to line this up so the gold pads are right underneath. There we go. Then I'm going to take some of this solder paste and just put it on here. And this metal sheet is going to block any of the areas that I don't want to put solder. But this stuff is legitimately a little bit hazardous. So before we get started, I'm going to put on some gloves. Also, I'm wearing a full hazmat suit, so I can't get any of this stuff on me. And I've got an air filter set up right behind my workstation. So oh yeah, that's an idea, Carlos. I could print out a jig that has a little hole, a little cutout for this, and then it just holds this in the right spot. That's pretty smart. Actually, I think what I'll do here is put this tape on, and I can pick this up and drop it down in the same spot. And then I just need some markings to help me put the PCB in the same spot every time. Like I said, I haven't done this type of PCB assembly before, So any pointers, especially those of you who are more electronically inclined than the rest of us, throw me those tips and we'll see if we can improve this process. Okay. Alright, that's just about where I want it. So I'm going to mark that location. And you'll know you got serial number 1 of this board if it's got Sharpie on the edges. Alright. We're off to a good start. Thanks for the tip, Carlos. Thanks beyond belief. Yeah, I'm learning today. Live on stream. There's going to be plenty of mistakes. Alright, so let's get some of this lead paste out. I've heard this stuff tastes sweet, but I'm not about to find out. Alright, so let's see how this goes. I don't know if it would be better to just put a big blob there and just smear it all around. ROH. Yeah, I'm definitely using the lead stuff because I heard it's easier to use. But maybe I'll try ROHS later. I think this syringe tip is more for use if you're going to be dabbing this on one board at a time. So I'm just going to go ahead and dispose of this safely. And I think I'm just going to put like a big blob down here, and I'll just reuse the same paste for multiple boards. Alright, and I think I should have a little container to set that lead solder in so I don't lose track of it. There we go. Alright, now I don't have a squeegee, but I think this might work. I get a lot of these with my 3D printers. So let's give it a try. That looks pretty good. I'm only slightly concerned about shorts between the leads there. How do you think I did? Alright, so now I have to place these little suckers on there. I have a feeling my hands are going to be too shaky for this. I don't know what kind of tools I need to help position these better. That looks pretty good. Oops. Alright, so this doesn't seem to be going so well. Alright, tweezer or forceps? Okay, I might have a pair of tweezers somewhere. But I'm worried that might make me even shakier since it's like out on a lever. All right, there we go. I think that looks pretty good. Now for my super scientific hot pot thing. As you can tell, I spared no expense with my hot plate. This is the same ones that they use, I guess, at a hot pot restaurant. Assemble on something else. Oh. I hope I didn't. Alright, I haven't made that mistake yet, but that's a good idea. I'll have a little extra workspace. Now this is going to be my hot plate. I figure it'll also be nice to have a cold plate, so when I set it down on here, it'll suck the heat out of the PCB, make it so I can handle it a little more quickly. Alright, so what kind of temperature should I be looking at here? Should I go with 1 or 7? Alright, beyond belief, go get that pizza. Oh, nice. Thanks for putting your order in, Adam. We'll get these put together. So in this first part, I'm just going to be doing these surface mount components. Once I've got all those finished, then I'll move over to the through hole. Side of the tube. Oh, yeah, that'll tell me what temperature to use. It says melting point 183 Celsius. So I just need a way to tell how hot that is. If only I had a thermometer or something. We'll see. I'm gonna guess mode 3 is gonna be the right setting. So let's just try this out. Let me get a nice close-up on this stuff as it melts. It's smoking a little bit. That might be the plate itself heating up and just releasing any grease that the manufacturer applied. I also have a heat gun and a couple torches. I don't know if those will come in handy. Oh, it looks like it's melting. We're getting some meltage. Let me know if you can see what's going on here. I might switch my camera to get it a little bit closer. That's looking nice and melty. On these three, it looks melted. The one in the middle isn't melted yet. I've looked at the heat pattern on this hot plate and it forms a ring. So anything towards the middle won't be as hot as along the induction ring, which is about a 4-inch circle in the middle diameter. Unexpected maker. Control board for adapting toaster. Oh, that sounds nice. So the real test here is once I'm finished with this, I'll look on the bottom and see if it's scorched. If I set the temperature setting too high, then I might have burnt the bottom. Oh yeah, Brian, one of them's definitely going to be yours. Okay, looks like we're finally getting meltage over here. Oh yeah, there we go. We're getting a little more close to the action now. I just want to wait for this last pad to melt. This one on the edge is taking a while to turn shiny. But it's starting to change now. You can see it kind of bubbling and changing from a matte color to a shiny color. That means it's just about done cooking. Alright, we'll take that off. Okay, it's a little bit smoky. Let me turn the temperature down to 1. So now I've got it on my cool plate. We're just cooling off a little bit. Let's look at the bottom side. Oh, it's in surprisingly good shape. You can see it's a little bit singed on that white paint. But that's plenty serviceable. Alright, so it looks good. Time to see if it passes the electrical test. But I can use my regular multimeter. That'll just beep if there's any shorts. So let's touch these 2 pins. Alright, I'd say that's a success. There's no beepage going on. All of these look pretty good. I'm going to give you a nice little close-up here. So you can see this is the stepper motor attachment point. We've got our fan attachment point. This one looks a little sus. I'm going to touch it up with a soldering iron. Actually, it's probably fine. Alright, so that's the proof of concept. Looks like things are working, so I'm going to go ahead and paste up a couple more of these boards. What would be really nice here is if I had two centering pins that the board just fit onto, and that would kind of lock it in the right spot for when I do this solder paste part. But I'm not, I think that first run worked pretty well. So I think we're good here. So I'm going to start doing this in kind of a batch system. I don't know if the solder paste dries out or what, so I probably don't want to use too much excess. From what I've seen when I've kind of watched, yeah, just a few more to go, Carlos. Is that on a metal plate? At what? And would those readings be messed by that? Is that on a metal? I'm not sure I understand your question, Patrick. You didn't miss much. I just finished the first one. I wasn't sure if I needed to clean these after I finished the assembly, but seeing how this paste gets everywhere, I'm probably going to give each of these a little scrub before I box them up and send them out, just to make sure I get all this paste off. Alright, here we go. I don't know if any of you guys play video games, but I could throw up a video game on the second monitor, have you watch some game footage while I build these bad boys. Also, I'm not sure how accurate I have to be with this solder paste. Doesn't it kind of wick into the right spot? Oh yeah, so games. Let's see, have you heard of RimWorld? I've got Rust, but that's a little too sweaty for me to play right now. I need something that can just kind of chill and play itself while I do this. Let's see. Yeah, I don't want to be going back and forth between my mouse and this work because I don't want to get lead on my mouse. I need to have like a special mouse for this. Alright, so let's see. We got another one here. So to anyone that's buying one of these, I'm kind of curious what kind of mods you have in mind for your printers. What do you want to plug into all these extra ports you're going to get? Animal Crossing. I haven't played that one before. Alright, I don't know if this is any good. You can see it's kind of blobby there. Is that too blobby? Or will it still work? With all that good capillary action that happens. Alright, bigger fans. I want to show you something that I'm working on. Well, it's not really pretty right now. I've got this giant box of fans, so let me get this out of the way. Alright, so we got Sunon fan, Creality fan, Sunon, Noctua, Sunon, Delta, another Sunon, a cheapo random brand, another Delta. So I've got about, I got a massive pile of fans here. Altogether, I've got maybe 35 different models from 5 or so different brands. So I'm going to find out which of these fans is going to be the best as a fan that runs natively on 24 volts. Stock fans on 7 machines. That's got to be loud. All right, well, hopefully they end up working pretty well. I'll have to get some feedback from you guys once I get these boards and everyone's on their printers. See how they're working out for you. All right, we got a batch. 6 of each connector. Is anyone interested in seeing one of these breakout boards for an Ender 3 V2 or like the Ender 3 Pro? I'm kind of curious if I should make another version of this that works on some of the older printers. Or if anyone would be interested in seeing a pick and place machine review or build. Because it would be nice to have a machine do this part that I'm doing right now. V2 would probably suit a lot of customers, yeah. Pro would be nice. Oh yeah, definitely. Between the S1 Pro and the regular S1, I think the regular S1 is kind of better. But I was talking about the Ender 3 Pro, the older one, with the power supply mounted on the side. I've got a design in mind for one of those, so I might come up with something for that next. I finally got my Ender 3 S1 Plus working. It was a bit of a process, but I got it working. It's pretty much the same as the Ender 3 S1, which is kind of what everyone would expect, but in a bigger size. The initial firmware that it shipped with wasn't working. Opulo would be a game. I'm not sure who or what Opulo is. Is that a YouTuber? I would Google it, but I've got these lead fingers on. I don't want to touch stuff. Alright, that's all the 2-pin connectors. Time for the 4-pin. Is Opulo a pick-and-place machine manufacturer? I think I might have actually heard of them. Like an open source thing. Oh man, this is not working out so well. Whew. Gonna really rely on the capillary action on that one. So I don't know how many Opula makes sells open source pick and place. Yeah. Are you sure it is lead based? Oh, really? Interesting. I did not think about that, but yeah, I'll have to get some lead-free solder for the European models. Thanks, Herzl. That's a good tip there. Don't want to be getting in trouble with the European authorities. But just to confirm, I have to be lead-free to sell in Europe? Oh no, Interpol's on the case. Well, I mean, in America, people still complain about having unleaded gasoline, so I'm pretty sure we're okay with lead in pretty much everything. Also, if you go fishing, you have lead fishing weights. I'm curious if in Europe they've outlawed lead fishing weights. And if so, what do you use instead? I guess you could have like tungsten fishing weights. So I've worked in the aerospace industry in the US, and we still use cadmium bolts on a lot of stuff, which as far as I know, those are not allowed in Europe. So Airbus and European brands, or the European manufacturers, have a directive to not use cadmium in their designs, which is used in like fasteners and bushings and stuff. Oh gosh. I'm smearing this paste around. I don't know if that's going to be okay. Some of these might need a little rework after Mr. Clicky snitches on me for creating shorts. But yeah, CRS1, I'll definitely reach out to Opulo. I'll send them an email and see if they can hook me up with a pick and place machine, because I'd really like to keep doing this manufacturing in-house. It gives you a lot more control over your output. Alright, I'm just about to put the last surface mount connector on. And I got some lead stuff on these gloves, so I'm gonna throw them away. Most of the contamination I'm getting on these gloves, it comes from when I'm placing the components. So I think if I get some tweezers, that'll really cut down on the contamination there. So right now, I'm going to set you up with a really nice shot so you can watch these things melt. All right, chat. Why? Why are you giving no thumbs up yet? Yeah, come on, chat. Where's the thumbs up? I see some thumbs up. We got 8 thumbs up as Excander. They might not be showing up on your side. Okay, so let's put a couple of these on the plate of heat. Alright, I'm gonna go grab some tweezers. Chat, you need to behave while I'm gone, okay? It'll just be a minute. And enjoy the view here. Only allowed for medical equipment. Dang. Alright, well, I'll get some lead-free solder. That shouldn't be too big of an issue. So now that we've got a nice little cycle set up here, I can solder while these things are heating up, place components while those are heating too. So we're gonna get a efficient little operation going here. Oop. No melting yet. I might have to turn the temperature up a little bit. But I'll just wait for them and see how this turns out. From what I know, I think you're supposed to use as little heat as possible to avoid burning stuff. And if it takes a little bit longer to melt, that's okay. Yes. The mother PCB. Looks kind of like a UFO. Oh yeah, there we go. I can speed up the melting. I don't want to burn these too much. As much as I do like torching things. I think I'm gonna bump this up to setting 2. I think 1 might just be a little bit too cold to get this solder to melt. I don't know if you can hear the... Okay. I don't know if you can hear the induction heater going off, but it's making like this little whining, clicky noise. It's kind of interesting. Let's see, I'll move the mic a little bit closer. It might get filtered out by the background noise filter. Oh, there we go, they're getting shiny. These ones are getting shiny. Let me know if you want to see these any closer. I can actually get a different lens on here that'll zoom in a little bit more. But it's not going to be a huge difference. This is about as close as we can get. Okay. It's just like a nice summer barbecue. Oh, shoot. This one's over a hole. That's not going to work. I think what I'm going to do from now on is position them so all of the stuff is in the middle of the plate. Oh, you can hear it switching. All right. Well, let me know if it bothers you too much. Okay. So I tried to bump this one. Oh. Oh, that's not good. What have I done? Shoot. Okay, that's a close one. Oh, you're scanning the QR code. Nice. Yeah, I don't have that set up yet. I'm going to update the website so you can see it's got some boilerplate nonsense on there. But yeah, once I ship these out, I'll make sure to have the website with the instructions up. This one looks good. Uh-oh. I'm going to have to... Well, I'm going to check every single unit to make sure that they're put together correctly. But especially this one. It's having a little bit of trouble there. Because I jostled it around a little too much. Oh, shoot. Uh-oh. One of them's smoking. It's probably this one. Hopefully that's just normal smoking. Oh. Yeah, I like that capillary action. You can see the parts, they kind of move into the right spot once everything gets liquefied. They're finding the state of minimum potential energy. Ooh. Picked up a hot board. This would be a lot easier if I had all the equipment, like a special little reflow oven and a pick and place machine and a proper jig for this solder. So we've got 1, 2, 3, 4, 5, 6, 7 done. That only took what? Half an hour? I'm gonna have to speed this up. So we've got 1, 2, 3, 4, 5, 6, 7 done. That only took about half an hour. At this rate, we'll be done in 7 hours. So I'll be up till 2 a.m. Okay, I'll try more solder. Yeah, I need to set up this jig properly so I can get things in position faster. I'd say these boards turned out pretty nice though. The gold plating, the matte black solder mask. It's very blingy. Alright. Now I'm going to try it with tweezers. See if this works any better. Push. I should look into the rest of building a Voron. I've actually got a custom printer design in mind that I want to make eventually. I think I'd probably put my money towards that rather than a Voron. Plus, from what I can tell, all of these super fast printers are all quite loud, because they're just like thrashing about and making a ton of noise. I'm more interested in building a slow printer with a high volumetric flow rate that's super quiet and easy to mod. And I'll have some clever ideas sprinkled in to make things just a little bit easier to build and modify. But if someone sent me a kit, I'd probably build a Voron. So is ROHS a thing in the US? I mean, I know a lot of things are labeled ROHS, but does it matter? Because any electronics project I've made is made with lead solder. Maybe I need to make these ROHS with, oh yeah, kick me down. I've had some channels reach out about maybe working together on this project specifically. I think this one's getting a little more attention because I'm making a commercial product. And I've reached out to a couple YouTubers about doing a collaboration. But I think I'll be able to... Oh, those products are labeled and don't have different versions. Okay. I think I'll be doing some collaborations in October, so if we stay tuned for a couple weeks, you'll be seeing me in possibly some other people's videos. I'll be interviewing some people from the maker community, going to a special event. So I think that'll be pretty fun, being able to see these people in person. I've got some hilarious skits that I'd like to do with some other 3D printer YouTubers. And if I can't find anyone to do them with, I'll just have to do them by myself. But it would be funnier if we had like an SNL style thing going on. It'd be very niche content for us 3D printer people. Alright, now I've got everything positioned on here, so it's all kind of, the components are in the middle where the plate gets hot. And let's keep this show on the road. I don't know how many of you saw the collaboration I did with Xometry, but that was pretty fun, going to their 3D printer factory and seeing all the industrial machines. I've got another contact that's more focused on laser cutters. So they've got a 650 watt laser cutter that we can check out. I think they also have some laser cutters that can make PCBs. So you just feed it the PCB stock and it can cut out all the traces and stuff, which would be great to have for me just to do prototyping work. It's a hybrid laser by a company called I think it's just Laser Systems or something. But it's got 3 different types of laser diode built into this one machine. So it can cut out the PCB and it can burn off the copper. So you can make all the traces and stuff. I'll be giving all of these boards a bath because when you're doing these soldering processes, when you're doing these soldering processes, it leaves behind little bits of solder. So you want to scrub them and get them all clean afterwards. This one I can tell is missing a little bit of solder, so I'm going to have to touch it up. Is there a way I can deposit more solder onto each of these boards? I think if I change the way that I'm squeegeeing, I might be able to get a little bit more. Handling the vapors, yeah. All right, kick me down. I'll do my best. A lot of YouTubers are just really busy too, so it's hard for us to collaborate. Between running the channel and stuff outside of YouTube, it's kind of hard to find the time to like drive to another state and do things with other people. But it would be fun. So Herzl, how'd you get so much electrical experience? You seem to know a thing or two about PCBs. Nice. Good work frying stuff, Herzl. That's definitely a good way to learn things. And thanks, Kick Me Down. I definitely try to add a little bit of sketch humor in the midst of things. I recently did a poll on my Patreon, and it turns out nobody wants to see 3D printer reviews, and I can understand why. Nobody wants to see laser cutter reviews, because I guess that's kind of unrelated to a lot of what you're interested in. But I get laser cutters in, and I think they're pretty cool, so it's something I'll continue to do occasionally. But I feel like the 3D printer review market is kind of saturated. Everyone's just spouting the same opinions. a lot of the times people aren't very critical. I don't know if they're worried about offending the companies that are making the printers and sending them free review units. But as far as I'm concerned, I don't really care if someone sends me something for free. I'm still going to give it an honest review because I think that's just a way that you can add value to people watching your videos. I mean, everybody knows all the stuff that they put on the box, and that pretty much every 3D printer can make decent prints if you tune your profiles and spend enough time with it. But yeah. Oh, that's funny, Herzl. Yeah, I have a really good barber. I don't see her enough, but she does a good job with my hair when I go. I get charged extra because she says, "You have a lot of hair." No, kick me down. Yeah, if I was in the Chicago area, I probably would have went to MTS, the manufacturing trade show. I think that was last month. That would have been fun to visit. And the ERRF, the Midwest Rep Rap Festival. That also would have been kind of fun. But I'll be going to ERRF, the East Coast Rep Rap Festival. That's going to be in a couple of weeks. So that's where I'm going to be meeting a lot of other YouTubers and hopefully building some collaborations and stuff. Oh yeah, I'll bring the mullet back. I miss the mullet. My barber, or I should call her a hairstylist, is pretty good. I just show her a picture of what I want and she makes it happen. So, if you all are in the Discord, I should add a Discord link to the video description. But it's in a lot of my other links if you want to find it. If you go in the Discord, just paste some hairstyles you want me to try so I can send them to my hairdresser and we can do some wacky stuff. Maybe a mohawk or just go full bald. Yeah. When it's another Ender 3 clone, those printers are just an overview of how well they implemented it. Yeah, there's definitely a lot of those. I like printers that try to do something new, improve the user experience in some way. That's why I liked the Artillery Sidewinder. Even though it is an older design, they've done a good job with changing the connectors, and I think it has a pretty decent breakout board built into the hot end already. Unlike Creality, they decided to go with more standard connectors, so you don't have to mess with stuff like this. It pretty much comes the way that I have this board designed, where it's got all the larger connectors up top. But unfortunately, there's so much critical mass behind Creality that everyone just recommends an Ender 3. That's not necessarily a bad thing, though. Because the more people that use that platform, you'll get more mods and stuff like this. I'm making a custom product for it because so many people have that printer. Alright, time for another batch. But if I designed a printer, I think you kind of know what I would prioritize based on the type of modding videos that I do. The positron, I haven't heard of that one. I'll look it up after the stream. Yeah, how many times can you review an Ender 3? Well, I've done it about 5 times. I'm working on a 6th one. I'll be reviewing the Ender 3 S1 Plus soon. I'm halfway through filming that video. But I've kind of turned it into a modding video. I actually put one of these breakout boards on it. I'm going to turn my air filter up a little bit. Hopefully let me know if the noise is too much. I can move it away from my microphone. Actually, I'll just go ahead and do that. But yeah, I'm working on another Ender 3 review, so stay tuned for that. I know everyone's excited about the latest flavor of the month of Ender 3. It was that S1 Plus that I was having issues with. I posted a video of it not working. And, yeah. That was annoying. I mean, Creality can't even pull off a successful Ender 3 clone, it seems like. So you have to wonder how important quality control is to these companies if they're shipping out products that don't work. It's pretty easy to do the math on it too. So if you look at it from a cost effectiveness perspective, it really doesn't make sense to do 100% testing like what I'll be doing for my products. I'm pretty much always going to be doing 100% testing on everything that I make. Because let's say you have 1 in 100 products that just doesn't work out of the box. Well, 3D printer companies don't really see a problem with that, because if you have 99 positive experiences and 1 bad experience, the person who gets the bad printer is definitely going to leave a review, or I should say they're very likely to leave a negative review, a 1-star on Amazon or whatever. But they're only a 1% of the population. And if the other 99 people don't have that quality control issue, then they're much less likely to report their experience. But let's say it's 10 times more likely that the person that gets the 1-star will talk. Okay, all right. Just reading through the comments now. Oh yeah, the positron. That one got a lot of views. That's a pretty cool idea. I would probably take it one step further and give it a portable power supply. But I'm sure that'd be easy enough to pull off. But anyways, as I was saying about the quality control issue, if 1 person out of 100 has an issue, they're going to leave a 1-star. And if you have 99 people that have no issue, they're going to leave like a 4 or 5 star and at a much lower rate. So then you'll end up with like 10 5-star. You'll end up with like 10 5-star reviews and one 1-star review. And that doesn't bring down the average enough to make any difference. So the product is still going to have a 4.5 star rating on Amazon. But you'll still have poor quality control that could ruin someone's day. So, I don't know. I think it makes more sense to just test them in the factory, make sure you're sending out good stuff. Because I would hate for someone to be in a situation where I sent out something that was broken, and then they're just relying on my goodwill to replace it for them. I mean, I'm the only person running this operation, so I'm kind of personally invested in making sure everyone has a good experience with this. But if you're looking at a big company like Creality, it's not really going to affect their bottom line if they just screw some customers over. These are all looking good. Yeah, I think heat level 2 is the sweet spot. It's melting everything, and we're not having any issues with the solder mask burning. You can see on this one, there's a potential issue right in here where those two might be bridged together. So I'm going to be doing touch-up on all of these afterwards. Be going in there with a soldering iron and some solder wick, just fixing everything up a little bit. But this is getting a majority of the work done, so that's good. Plus, it looks a lot cleaner than if I do these with just a soldering iron like this. All right, Dave something. I'm gonna read through the comments now. Give me a sec. So, my hair is almost as long. Yeah, I have that. Sometimes I get like the cowlick on the back of my head if I get my hair cut in the wrong way. But I've got my person that does my hair right now is really good at avoiding that issue. Oh, you think I should test a few, Herzl? All right. Let me finish up these last 3 that I have here. Oh wait, I'll finish up. I'll get this last batch of 4 cooking, and then I'll start testing a couple of them, just to make sure we're not on too much of a wrong path. Plus, I know you want to see Mr. Clicky, so we'll get to that before you have to go to bed. Alright, yeah. Okay, so I'll finish putting these components on, these last 4, and then I'll finish assembly on a couple of those so we can test them. I at least need the 24-pin connector on there before I can run Mr. Clicky on it. I actually know a guy that locally does PCB manufacturing. So he has a little pick and place machine and does all the reflow and stuff. So I'll have to see what his rates are. Anyone hear any exciting news on fast-acting relays? Is okay. Yeah, it does sound pretty fun. All the clicky noises. I could turn the speed up even faster, but at a certain point, it's kind of hard to see what the test results are showing. Everything just flashes really quickly. So I'll show you some of the packaging that I'm going to be using for these. You might get a kick out of it. So all of them are going to be sent out in a gold, well, at least the first 100 are going to be sent out on a gold satchel like this. And each one is going to have one of these stickers in the box. So this has the QR code. It's the same one that's on the PCB itself, but once you have the PCB all built and assembled, it might be hard to see get access to that QR code. So you can just slap this anywhere on your printer, and then if you need a quick reference guide for which pins do what, or like voltage or current limits that might be applicable, you can just scan that and get a quick reference guide. So hopefully that'll help some of you out. Plus it looks cool. It's my little logo thing. All right, one more of these. Three more of these. So I don't know if you've all heard my thoughts Oh yeah, QR codes are cool. A great use of space to portray information. But I don't know if you've heard my thoughts on this, but this whole ordeal of having to use a third-party product like this just to plug things into your Ender 3 totally goes against the whole idea of the Ender 3 and what made it such a popular printer in the first place. So originally, everybody loved their Ender 3 because you could just modify it however you wanted. And now they put all these tiny little connectors on there. And it's like, well, shoot. You deeply distrust them. Oh. Yeah, I guess if it got scratched or something, the QR code could become unreadable. Whereas if you have text, your brain can kind of fill in the blanks for the scratched spaces. But yeah, I think it's just kind of Creality selling out a little bit in terms of what their values are. I don't think the new Ender 3 is even open source like the original one was. You can open up a Fusion 360 model of the whole Ender 3, like the original one, and see every little detail about how it's put together. And that kind of backfired on them, I guess, because so many companies just cloned their design. It's like they just went on Alibaba and sent out that design to 100 manufacturers, and it's like, can you please make this for me? Someone's making a lot of money selling these, so I want you to make some. Yeah, the open source model seems a little bit broken in the face of all these Chinese manufacturers ripping everyone off. Alright, so let's get ready for the next phase of production. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we've got 19 boards. Sorry it's a prime number. I know everybody likes even numbers, but we're not so lucky today. I'll get these 19 boards soldered together with the through-hole connections. And we'll try out Mr. Clicky and see what our pass rate is, how many errors we're getting on our boards and all that. So now I'm going to be breaking off chunks of these connectors for these 24-pin connectors up top. Does anyone have any recommendations for premium tools? You know I like premium tools. I've got my Nipex pliers. Great stuff. My Mitutoyo calipers. They've got like a 24-month battery life if you just leave them on like this. It's absolutely crazy what they've done. Alright, I'm confused. I don't know if I should leave this paste here. If anyone knows what I should do to clean those up. Yeah, after 100 I'll call up my buddy and have him make them all for me. Now I'm in this for the long run. I signed up to build them all, so I'm going to build this whole first batch by myself. I'm going to lump this up. I'm just going to make this into a pile to minimize its surface area. That way, hopefully, I'll get the least amount of dried up stuff when I'm done. I don't want to waste it. I could really use a new multimeter. I'm using this old crappy one from a hardware store. Runs on a single 12-volt battery, or 9-volt. Alright, these all look done. We're done with the hot plate for now. Alright, so 19 down. Let's see how long that took. Let's see. I'm going to refresh my stream and see how long I've been doing this. 99 minutes? Alright. Let's do some math here. So, 99 divided by 19. Okay, so I'm doing... Oh, geez, I'm slow. That's like 5 minutes per board. Just for the surface mount components. But there's a learning curve involved there. We'll get faster. Alright, I want to see your tool recommendations. Tabletop multimeter, nice. Yeah, I want to get a tabletop multimeter. I had one at my last job, and you know, you can measure milliohms. You can almost measure how long a piece of wire is based on its resistance. Oh yeah, you have the world's worst tools. Oh, the calipers, these are Mitutoyo. I like them a lot. You can get them on Amazon Prime. But they're super repeatable. Like if you get the cheap hardware store calipers, when you open it up and close it, it rarely goes back to the same number. These ones go back to 0 every time. Super reliable, unless I bump it open a little bit. I mean, you're measuring such small values that... Yep, and they have a digital output, I think. I don't know if these ones have it, but some of them have a digital output, so you can plug them into your computer. And like if you had 100 things you wanted to measure, you can just press enter and it outputs the number for you. Alright, let me see what else we got. Herzl's got his 3K multimeter. Why would you spend extra money on leads? You talking about these things? Cheap leads are annoying, dull probes. Yeah, I guess so. Yeah, I mean, when I press onto things, sometimes it doesn't make an electrical connection. So I guess that would actually save a lot of time if I had some better leads. One of my favorite measurement tools is called, I forget what it's called. It's an optical comparometer. I'll post a link to it in the YouTube chat. But I use this tool for a couple of my previous jobs, and I've got contact with one of the sales reps. So I might be able to get a like a demonstration of it. It's a super cool tool. Uh-oh. This one's bad. I'll post a link, one sec. This is the tool to get if you've got a ton of money sitting around. Maybe they'll give me one for free for a YouTube review. Oh, the Sonic Pad. I'm scared of that thing. I want to try one out and just see what it's like. But I would imagine that if you get your own setup and build Clipper out the way that it's supposed to be, it might be a little bit better. I definitely think that having more printers with Clipper running is a good thing, because you get a lot more control over how the printer works, and you don't have to flash firmware onto the machine every time you want to change some little setting, like whether the limit switch acts as a open circuit or a closed circuit. Like, you can end up wasting hours of your life recompiling Marlin firmware to get things working. Alright, we've got 10, 14. Just need 4 more. I don't know if there's a way to buy these pre-cut, but I wasn't having very much luck finding affordable options for these already cut in the right length. I think 2mm pin header is kind of uncommon to begin with. But that's part of Creality's game. I think they wanted to use 2mm pin header just to make things less compatible with other devices. Nobody likes 2mm pin header. It's harder to solder. It's these tinier connectors that can't carry as much current. The parts for it are more expensive. They probably locked down a couple suppliers buying out their whole inventory so nobody else can make Ender 3-like devices. But this is my workaround, just cutting out these little pin headers. They seem to do the job pretty well. So we've got 4, 4, 4, 12, 16, 17, 18. Last one. All right, 19 pin headers. Time to get some good old-fashioned soldering done. Let me get my soldering iron in frame so you can see what I'm working with here. Boom. You all know of Hako? I don't know how to pronounce that. Hako. Oh, shoot. There's a bit of a stream delay. Oof, that's still hot. Let's get rid of this plate. So, funny story about these plates. These are AR500 plates. They're bulletproof, so that's kind of cool. That comparator, yeah. I have a big jar of pennies somewhere in my house. Yeah, they're like $20,000. They're really cool. So you can design a profile. So you just, like, let's say you designed a profile for this tool. You could just set it on the comparometer, and it'll scan everything about it and tell you all the critical dimensions that you tell it to look at. I mean, you could use it for analyzing PCBs and making sure they're manufactured properly. So those tools are amazing for quality control. Yeah, these steel plates aren't like wimpy Kevlar bulletproof. They're like full rifle round bulletproof. So there's probably some fun stuff that I could do with them. Alright, we're done with the hot plate. I'm going to put that back in the kitchen. Just kidding, it's not going back in the kitchen. Definitely going to quarantine that thing and never use it for food again. And this plate got nice and warm just from cooling off the PCBs. All right. Soldering time. Yeah, thanks for mentioning that, Herzl. I don't want to get in trouble with the European authorities. So I'll be buying some non-lead solder. I might need to get like a sticker or something that says ROHS. So let's get this zoomed in as possible. Hold on, I'm going to give you a nice front row seat to this soldering action. Okay. Wow. I like my camera. This is great. All right, and while we're up close looking at this board, I want to show you my favorite little detail. Can you see what it is? It's gold. I love gold. I like that little gold logo there. That's so cool. Okay, so now I'm going to be soldering these pins in place. I'll show you kind of my strategy for this. I need an extra pair of hands here. Well, first I'll just... Yeah, so I'm using a chisel tip. This is what came on the soldering iron. So I don't know of any other thing. I've had this tip on the whole time that I've had the soldering iron. But it's a good all-purpose tip. It transfers a lot of heat. So even when I'm soldering larger objects, it can dump the heat and get things melted. So I'm just going to tack both sides of the board. Just like that. And helping hands. I actually have some helping hands. I've never needed to use them before, but I think this project might be the thing that makes me break them out and figure out how they work. Let me take off the lens hood of my... there we go. I get a little bit of extra light in there. So the way that I've been doing this is just kind of melting a giant blob over everything and engulfing all of the leads. I don't know if there's a better strategy for this. Oh shoot. So what I've been doing is just solder blobbing this whole thing. I'll get to the comments in a second. I know a lot of you are probably cringing at this horrible strategy I'm using. Must concentrate. And I drag it off to this side purposely because these 4 pins are electrically connected together. Oh wow, there's a lot of reflections there. But yeah, I drag it from left to right because these 4 pins are electrically tied together. So it doesn't matter if there's solder hooking these together. It'll still work as intended. And I get pretty clean solder. I get a pretty clean result across all these pins. All right. You know the trick involving breadboard to solder headers? No, I don't. Apparently. I do them one by one. I don't have to do 2,400 of them. Yeah. This is fine. Breadboard's the best way, and you can also use some blue tack. So what is blue tack? I hear that all the time. Is it just the blue 3M painter's tape? Or is it some kind of like adhesive? So there's the other side. Looks pretty good here. And then I got a big jug of cleaner, so let me bust that out. And this is probably another one of those things that I should put gloves on for. What do you think? Gloves? Is it glove time? Oh, yeah. Oh, okay. So, I don't have a 2mm breadboard, but that's something I could buy. I do have one thing that might help. I'm going to grab it. I've heard preheating the boards might help with this type of soldering that I'm doing. Yeah, it turns you into Captain Marvel. Definitely. You just pour it all over your hands and light a match, and then you have fire hands. You can shoot fireballs. I'm not sure if this one's yours, Mazercore, but if you put in a special request, I might be able to mark it in some way, make sure it goes to you. But you might not want this one. Yeah, Creality uses the 2mm. I have a... hold on, I gotta be careful with this. I don't have a funnel or anything, so this is gonna be fun. Holy cow. Oh my. This stuff is, must be a powerful solvent. You can see it, I leaked some on the side here, and it's dissolving the paint pretty much immediately. So yeah, this is something I'm going to want to wear gloves for and use sparingly. Oh yeah, take a shot? Yeah, sure. We'll make a drinking game out of this. I've got some other stuff that's worth drinking, but not this. Okay. Now I put it in this little bottle so I can shoot it up directly into my veins. I'll put like just a little drop of it on there. And we'll give it a little brush. Yeah. Well, so much for the matte finish. I might need to get an ultrasonic cleaner or something to get this fully cleaned off. That didn't do too bad. Alright, that's good enough. These are supposed to be lint-free rags that I'm cleaning these up with, but I don't think it's really lint-free after they get ground up. ISO? Okay. Hello, Kick FPV. Welcome. Don't use your torch near heptane. Why not? I mean, of course it's flammable, but is there anything worse about it? I've got this no clean liquid flux someone recommended, but it, oh shit. But it came in a bottle that doesn't have a little dispenser on it. So it's almost impossible to use. Well, now that I got it all out here, I might as well solder with it. Oh, jeez, it's hissing. Alright, I'm just kind of having fun with these. Once I get into production mode, I'll be moving a bit faster. But this is all new. Fun stuff. The hardest part about soldering these pads on the left here is how much heat you have to sink into the copper board itself. Because this is where my heavy leads that go to the heater cartridge are. Okay. Well, let's fire up Mr. Clicky and see how this one does. I'm not too concerned about the through-hole components not being on here because those ones aren't going to cause nearly as much issues as the surface mount ones. Just because through-hole, it's almost impossible, at least on the 2.54 millimeter things. It's almost impossible to short these together when you're manufacturing them. These 2 millimeter pins are a bit of another story. They could be shorted together if you don't do it properly. So that's just another thing that's kind of annoying about Creality using these. But yeah, this looks pretty good. Let's give it a test. So, time to introduce Mr. Clicky for the third time. Okay, yeah, soldering pin by pin should be less messy. Yeah, it seems like it would be slower at first, but when you consider how much time I have to spend cleaning things up, it's probably easier to solder pin by pin. I am, yeah, I'm wearing a full Tyvek suit. You know, gotta be safe. I'm leaving my my face mask off though, for now. Otherwise, I'm gonna sound like Bane this whole time. All right, so I'm ready to do a test. So one thing that I should do is I need to validate Mr. Clicky and make sure that it's testing everything correctly. So the way I'm going to do that is soldering irons on. I'm going to make a test plug. So for this, I'm just going to solder all the connections together. So it'll be just like a big short. And that way, I can validate that Mr. Clicky is detecting each type of short. Actually, it'll be easier if I do this on an old board. So normally you don't want shorts, but on this one, I'm just going to load it up with a bunch of shorts. So you can test all of your products and say, oh yeah, my test machine signed off on all of these products, everything should be good. But you need to make sure that your test equipment is calibrated and validated and properly working. Because there's a possibility that if your test equipment is not working, it's producing the wrong test data. So by creating a gigantic short across every single pin on the back here, this will give me a test case where I can just plug in Mr. Clicky and see if all the lights are lighting up. Because if anything was wired wrong in its internal wiring, then some of these lights might not turn on. So we're first going to validate that when every pin is shorted, all of the lights should turn on every time. So let's plug it into our test board. All right, so here goes. This is going to be bright. Yeah, so every single one's turning on, which is what you'd expect, except for the last one, which isn't wired to anything. Ah, my eyes. Okay, hold on. Let me dim this down a little bit for you. So you can see every single one is turning on because there's a short between every single pin. And that's what we'd want to see. The reason why the last one turns on independently is there's 15 pin groups that I'm comparing here, and one of them is not assigned. So that's all good, and when I unplug this, which simulates a short between each pin group, we should light up one at a time. So just like that, we've validated that this whole machine is working as intended. Now I'm going to go ahead and plug in the board I actually want to test instead of our dummy board that was just validating that the machine works. So when we plug in this test board, it should turn on just one. Oh. All right, this isn't a good start. So what do you think? Is this better or worse than you're expecting? All right, wow. So I've got a lot of shorts here. Now the question is, where are these shorts? Oh, shoot. Yeah, the Alien movie. It kind of reminds me of Stranger Things. Solder beneath the 24-pin header. I'll take a look at it. Good job, Mr. Clicky. You're keeping us safe. Alright, so let's investigate the board. It's possible that these were all bad from the factory, from PCBWay, but it's extremely unlikely because they have a pretty good level of quality control. So the issue has to be with the way that I put these together. Hers is saying to look underneath the pin header. So on this side, everything looks clean, except for obviously these areas where they're all joined together. We'll zoom in here. So this all looks good to me, where these pins are joined together. There's no obvious shorts between them, except for this group of 4 and this group of 4, which are all electronically hooked up together anyways. So that's probably not the issue. We can't really see it on this side. So what I'm guessing happened is solder crept through these joints and got into the back side. So if we take off this plastic piece, we can see behind it. I have to be careful with how I do this, though. Yeah, I think hers is right. Let's see. Herzl. If you look in there, you can kind of see something going on. So I'll try and pull these off. Alright, so now we can see under these pins a little bit. I can't really tell what's going on, but I'll try hitting it with the soldering iron. I'll give you a good view of what's going on here. Oh, it's also possible that I put the connector on backwards. Yeah, it's possible I put the connector on backwards. Let me try this again. I need to put it on like the... Alright. Big brain time. So I plugged it in like this. I need to plug it in like this. I hooked it up backwards. So let me push this back down. I'm participating in a wild goose chase right now, I think. Let me get caught up with the comments. All right. Cable in the right direction. GH, I should have read your comment a little while ago. It would have saved me a lot of time. All right. Because this group of 4 is soldered together and that group of 4 is soldered together. And, you know, that should correspond to this group of 4 and that group of 4. Backwards cable. It happens. All right, let's try Mr. Clicky again. There we go. G2HO had the right answer. Carlos, you missed the Clickmeister. No, we got it. Clicky's going to be going on for at least the next little while here. All right. So that was a lot of concern about a problem that wasn't real. But that's okay. You know, it's much more important for us to try and figure things out and overcorrect and whatever. But this one's good. It's been good the whole time. Still works even? Yeah, it does. These things are built to work. All right, I'm going to put a couple more of these together with the 24-pin headers that I've cut out. Let me press this plastic piece back down. So I'm actually working on a version of this for an Ender 3 V2. Which is going to be really exciting because I'm going to be putting some unique flavor into the Ender 3 modding scene with this this V2 version. It'll work for the V2, the VoxLab Aquila, and basically all those older style Ender 3 clones. So stay tuned for that announcement. I'm going to be doing a full reveal of the design in probably 2 or 3 weeks. But I've got to get some more stuff lined up, and obviously I'm going to be pretty busy putting these together as well for the next couple weeks. Whew. Yeah, so King said this doesn't work with the V2 unless you get a Sprite hot end cable. So yeah, Ender 5 it works for all of the 3D printers that use the Sprite hot end because it's built around Let me get the cable for you so you can see. It's built around this 24-pin connector that the Ender 3 S1 uses. So hopefully I made that clear enough in the videos. Yeah, if you have the Sprite Pro kits, then it should work because that's the same cable interface. But yeah, hopefully people haven't ordered this thinking that it'll work on a regular Ender 3. That would be awkward. But, you know, we can always cancel the order and put in an order for the next one when that comes out, because it shouldn't be too far away. Yeah, so the Sprite Pro kit that King Sidorak is talking about, that's basically it's the Ender 3 Sprite upgrade kit. So you can put the Sprite hot end on your older Ender 3s. Okay, so with that drama averted, thankfully it's not too big of a deal. I'm going to finish up these 19 boards. I'm going to put the 24-pin connector in there. This is going to be great. Boo! Zoom. Yeah, that would have been a really bad omen if the first board that I made had a bunch of shorts on it like that. You had me worried for a second there. If you make adapters, then you won't have to design a new board. That's true, but I bought one of those kits and I want to review the Sprite upgrade kit. I think it's kind of going in the wrong direction. I think settling on Creality's random 24-pin mount is not going to be good for the ecosystem and the community long run. I gotta take a quick 1-minute break. I'll be right back. Sorry about that. I had a bug alert. You know that's very important when a bug is in the house. All right, so give me a holler if you're still in the chat. All right. So yeah, there's a bug in the house. You know, it's very important that I go kill the bugs when those appear. All right, back to business. So after that little fiasco and all the cleanup I had to do, I think I'm just going to solder these pins one at a time. My expert counsel has informed me that's the best way to go. But yeah, have you taken a look at that adapter cable for the Sprite upgrade? That thing looks like a mess. I'm just concerned that it'd be difficult to put that thing together reliably. But I guess there's ways to do it, well, with modern quality control. But I have a cool solution coming up, so I don't want to spoil it, but let's just say it'll open up a lot of doors for customization for the look and color of your machine. And also, I'm going to make it as idiot-proof as possible. So you could put it together and plug everything in and backwards, and it'll still work. Not saying that you guys need that kind of help, but it's nice to have. Because as you can see, I plugged something in backwards just now. It's a common mistake. All right. It's not a bug, it's a feature. Yeah. Yeah, the thing with sharing a common ground across all of your wires is if you have a wire come unplugged from your hot end, you might send the whole like 2 amps of current that it takes to run the heater cartridge through some random pin that goes to ground that's intended for your fans. So you might end up, if things aren't designed properly, you might end up sending 2 amps through a tiny little wire that can't handle it. That's one of the things that I was really thinking about when coming up with a wiring scheme. But yeah, when I announce that project, I'm going to release all of the schematics. So if other 3D printer manufacturers want to use it, I think it would be kind of for the better. I just want that street cred. It would make sense to have a set of standards for 3D printers too, for the way that certain wires and connectors are done. Just like with light bulbs or electrical outlet plugs or PC hardware. Like you can plug in any graphics card to pretty much any motherboard and it just works. PCI, ATX. That's the kind of stuff that needs to happen for 3D printing to make it a little more accessible and easy for people to build and modify their own machines. And by the way, those 2 pins on the end are supposed to be shorted together, so I don't mind if there's a solder bridge between them. That's the nice thing about knowing this circuit inside and out, is I know when it's okay to have quote-unquote manufacturing flaws. Yeah, this is a lot cleaner, just doing them one at a time. So I'll be doing it this way from here on out. Cool. Does anyone know of a good way to clean PCBs? I was thinking about getting an ultrasonic bath. Make them call the feature NBR. Okay. Yeah, I should call it that. Maybe like the NBR standard or NBR connector. It's like all those people that invented like physical equations. Like Heisenberg's uncertainty theorem. Or you could be boring and like most industries just call it like ISO 12250 standard for connector thing. Man, I was really worried about that first plugin. I was like, oh shit, I don't know if I can do this. So I'm glad it worked itself out. So anyone know of any hot new 3D printing trends coming up? 20 useless certs, yep. My favorite is when there's like a standard, and then you have to pay someone to download the standard. By the way, all of the printers that I've reviewed or used on the channel, I still have all of them. I need to figure out how to get rid of these printers. I've got like 16 printers right now. I've got an inventory list, so I'm starting to track it. The first step is realizing that you have a problem. That's looking nice. Let's get a close up. Oh, come on. There we go. Interested in the V2s? Yeah, so I'm working on an inventory list, and I'm noting what all the mods are. I'll actually share that document with you. 1 second. I'll paste it here. I could recommend the S1. It's not a bad printer. Or you can save up for when I release the NBR printer. Alright. Alright, I'm going to paste the link into the chat so you can see my 3D printer inventory. All of our DINs, German industry standards, are under the Booth industry and want money for everything. Yeah, that kind of sucks. I mean, the same thing happens with academic papers. The government pays to have all these people do research, and then the research institutions publish the papers they publish the articles places that nobody can get access to them. Kind of sucks. There's a couple there's a couple, what do you call them? There's a couple institutions that are, I mean, there's more than a couple. There's a bunch of them that just publish all of their research, which I think is pretty cool. One of them is HAL in France. I don't know what it stands for, but it's HAL. I've read a lot of their papers and done research on kind of expanding their work. Super fun stuff. A lot of things to do with additive manufacturing. Has anyone in the chat made custom PCBs before? I'm kind of curious if anyone's got experience with that. Because PCBWay is interested in having people use their service, obviously. I think PCB technologies is pretty awesome because you can just make superconductive leads to do things. One of the videos I'm working on is for a PCB motor. There's a guy, Carl Bujeja, that has done some PCB motor work. But the type that I'm familiar with is a completely different style that's more suitable for like medium to large size motors. HAL 9000. BQB1. I would actually like to try out a BQB1. They do some really interesting stuff. Overall, I'm a pretty big fan of what BQ does. They're owned by the same company that does Big Tree Tech. And Big Tree Tech has some of the best main boards on the market. Yeah, the S1 is a good way to get all of the mods that you would normally put on a regular Ender 3. So Alan, thanks for your order. Yes, one of these will be yours. Hopefully it'll be the one that works. Just kidding, they're all going to work. If any of them don't pass the test, then I'm just going to have to rework it. Basically troubleshoot it, figure out where the short is, and fix it. Yeah, so King said this is pretty much the premium sprite control board. I mean, it's not a control board, it's just a breakout board. So it takes the ribbon cable from the regular Ender 3 S1 ribbon cable, and it splits it out into a bunch of extra ports. So let me just finish putting this one together, and I'll show you what the final product is going to look like. So hers, I've worked with a DIN rail, DIN rail. It's like this metal connector thing that's used for um, securing electrical components, usually in like control boxes and control panels. Is that from the German standard, DIN? Sci-Hub, okay. Um, yeah, so I learned how to do PCB design kind of like on a weekend when I had a project at work that could really use a custom PCB. Um, I'm using Altium. It's a really great piece of software. It's kind of the best in the industry. It's kind of like the SolidWorks of PCB design software. And you get a 30-day free trial. I'm pretty sure they give it to everyone, but they gave me a custom link so they can track like how many people I'm referring. But that software is amazing. I can show you a little bit of what Altium looks like, since I run it on the computer that I'm streaming off of right now. But it's got this really cool feature that it almost makes PCB design too easy. So you may have heard of KiCad. It's KICAD. That's one of the alternatives. I'm going to open up some Altium so you can see kind of the stuff that I'm working on. All right. Screen. All right, so you see my screen now over here. I don't know how well the audio and the video is synced up on the stream, but let's say we want to start a new design. So new schematic. So this is kind of your blank slate. And what's something that you want to make? Let's say I want to make a cable or a PCB that has just a connector and an LED on it. So I can go into this manufacturer part search and type in LED. And it gives me all of these LEDs. So I can double click on them and look at the data sheet. So I just click on it and it pulls up this data sheet here. So it gives you all the information about it. And you can drag and drop it onto your schematic. Then say I want a 2-pin connector. I'll use the JST connector, which is kind of the one that I'm using all over this board. So one of these 90-degree surface mount JST connectors. And then I'll throw in a resistor too, just to make it more of a complete circuit. It's pretty common to use a current limiting resistor on your board. So I can use a surface mount resistor here. Let's say 1100 ohms. I don't know if that's the right number to use for this, but I can just drag and drop it in here. Control W, wire this up. Cool, so now I've got my circuit here. These two pins on the side are just the mounting pads. You can see those on the surface mount components that I've been using. Okay, good. Audio and video is synced up. You click on the circuit breakers, etc. on them. Well, yeah, so, all right, so I've got my schematic all set up here, and then I want to make a new circuit from this design, so new PCB, and I need to save this as LED board. I'm kind of a noob with this software, I'm going to be honest. So I need to make a new project, LED PCB, and I need to drag out all my documents into that one project. So I'm not the best at this kind of stuff right now. So now import changes. Oh wait, no. Update, skip, no. Well, anyways, this is a live demo, you know. It doesn't ever work how you want it to. Import changes. That should work. I swear I know how to use the software. I built the whole circuit board using this. But normally I have one project open at a time, which simplifies all this. Import. Okay, here we go. Execute changes. And that brings all of my components in. And then I just need to add wires connecting everything. It gives me little lines showing me where to draw these connections. Ta-da, there we go, there's my board. I'll do one loop around the outside to define my board shape. And then I kind of want to do a more in-depth oh, I can just draw the board shape like this. I should have done that. Anyways, I'm taking some shortcuts here. And then tools. I'm making this look very difficult. Define board shape. Well, I don't know. We'll just go with, we'll just see what this looks like. I hit this button and it goes to the 3D view. I did the opposite of what I wanted to. I just cut out a hole in the board. That's not good. But yeah, I mean, there's my PCB. I need to cut it out so that it's just this thing on the edge. But this is the basic process. The nice thing about it is all of these pads and all these little like footprints are preloaded into the software using their manufacturer part search. So you don't have to learn like all the detailed bits of how to design the pads and the specific shapes. A lot of the hard work is done for you. So you can just like drag and drop components in. And that's how I did my whole design for this breakout board. All right, back to the fun stuff. I think I'm gonna just finish. I don't think I'm gonna make it to 100 tonight. Just being honest with you guys. At this rate, I'm probably gonna make it to 10. Plus, apparently I'm not going to get any of the European boards done tonight since I need to buy some lead-free solder. Do you think they allow lead in space hardware? You said it's just for medical devices, which seems a little backwards to me. Oh, yeah. Do you mean the software looks manageable? Questions, where do you keep the bodies? Which bodies? Are we talking about the bodies of all the 3D printers that I've slain? Yeah. Most lead is going to burn up on re-entry, if anything. Yeah, I agree, Adam. I've used lead-free solder before, and it was a little more difficult to get it to flow and to stick to stuff. But them's the rules you gotta play by to sell things in the EU, apparently. Their precious health. K27, there's no dead bodies. This is getting a little out of hand. I'm sorry, K27. Goodbye. Yeah. Not all my printers make it out of the lab in that great a shape. um, you know, a lot of people like to say silly stuff on the internet. I'm gonna put them in timeout. Oh yeah, King Sid and hers, since I know you guys from Discord, I'm just going to add you as moderators if you want to take care of stuff like that. Don't let the power go to your head. Just kidding. Right. Yeah, European health protections are, I would say, a good thing overall. It can be annoying, but there are workarounds for pretty much everything. All these other solutions that aren't environmentally friendly. I mean, I'm all for using the right materials for the job, but there comes a point with, say, lead and cadmium where you're literally causing permanent nerve damage to people who are improperly exposed to it. So, I mean, it's kind of a good thing to manage those materials with a little more scrutiny. But I'm still curious, what do you guys use for fishing weights? Because in the States, if you go fishing, you put a lure in the water and it's held down by a lead weight. Which doesn't seem like that great of an idea because you're basically introducing lead into a waterway that people use to eat and drink out of. Ban hers for being competition. Okay. Yes, hers. You deserve it. What's wrong with PTFE? Do they ban that in Europe too? I'm really not a fan of PTFE just because the fluorinated badness that it has. So I always upgrade my printers to all metal. I mean, 3D printing in general has a lot of exposure risks that people like to downplay. So I've always got my my air filter running. Hashtag not a sponsor. Now you gotta wonder, what game have I played for 1,400 hours? The binder of PTFE is a compound that will never disintegrate. Yeah. Yeah, I'm not a fan of PTFE. In basically every mod video I do, I put an all-metal hot end in. Plus, all-metal hot ends are more effective as... oh crap, I put too many pins together. All-metal hot ends are more effective as heat breaks because the walls are so thin. So you end up needing a less powerful hot end fan to keep everything cool. So I've heard a lot of people say that the Noctua fans aren't powerful enough to keep their hot ends cool, and they get issues with heat creep. But I've never had any issues with my Noctua fans, and I wonder if it's because I also upgrade to all metal hot ends on all of my printers. What's wrong with fluorine? Yeah, so I don't use non-stick cookware either whenever I can. Because it's PTFE lined. That seems like an awful idea, isn't it? Well, my brown pants are PTFE lined, so it just slides right off. Yeah, a lot of people talk about how Bowden tubes are better, and I'm like, what are you talking about? Like, there's no way in hell that it's better. On every printer that I've upgraded to a direct drive extruder, I immediately get better print quality without having to do any tuning or anything. Oh, tin and brass. That makes sense. That probably looks cooler, having brass fishing weights. It's more steampunk. So while we've got chat here, what do you guys want to see if I were to develop a 3D printer from the ground up? So I've got some ideas. Mostly I would want to get rid of fans as much as possible. And I don't think it's really necessary to have so many fans on a 3D printer. I don't know if you guys have seen this one, but I have an older video about making an Ender 3 without any fans. It's the first and only episode of Pimp My Printer with Nathan Builds Robots. Cheap Core XY or possibly Core XYZ. I didn't know there was a Core XYZ. That sounds like a Delta printer to me. Yeah, I don't know about the shop compressor either. That's even louder. But much more effective. I was thinking about making a video with, you know those little air, they like vaporize water. And you can put like essential oils in them and it makes like a nice little fog. I was thinking about putting that on the hot end for like extreme part cooling applications. Obviously, it's not a very practical idea, but I'd be curious to see how it works. It might work out really well. Because you can dump like many BTUs of cooling into a system. I'm sorry for the European audience for using the BTU. Ooh, that was a tough one. Fans suboptimal. 1 or 2 videos of Core XYZ. So what it sounds like to me is you've got 3 motors and none of them directly control a single axis, which sounds horribly complicated. What I don't like about Core XY is I don't understand it. I could figure it out. I mean, I've worked on kinematic systems before, so I could figure it out. But the belts system seems really complicated. And just getting that tuned and tightening everything up. Versus a standard Cartesian printer, you just tighten up each belt on its own, and it seems really simple. It's kind of the most simple solution. I was going to say elegant, but I mean, I think it's too simple to be elegant. Yeah, that's right. British thermal unit is European. So is the pound and the foot. Yeah, the upside down printer, that one looks interesting. Do you know if anyone's making a kit for that? So you could, like, if you could buy one? Because that might be interesting to get one. So these boards that I just made are gold plated, but if you look at the other ones that I built, those are made with HASL, hassle, and that's like a pretty cool process if you've ever read up on it. I don't mind having a slow speed printer. Like a lot of my high, I guess like high speed printers aren't fast in the sense that the printer moves quickly, but they're fast in that the extruder extrudes a ton of plastic in a short amount of time. So you get really fat layers. I think you end up with better mechanical properties that way. Because the layers get really fused together. Dun dun dun. All right. That is. Let's see how many we got left. 1, 2, 3, 4, 5, 6, 7, 8. So I got 11 of those connectors down and 8 more to go. And then I'll solder on all the rest of the through-hole components. I think if I get 19 done tonight, that'll be a pretty good start. I still have to pack the printers too. I'm not sure who it was that asked about this. Okay, the developer is looking to find someone who will produce it. Docs as a CC license. Oh yeah, so the process is called hot air solder leveling. They use like a blade. It's kind of like those the Dyson Airblade hand cleaners. Like if you go to the bathroom and you just like put your hands in, you pull them out, and there's an air blade that like gets all the water off. They do the same thing, but they use an air blade of hot air to blow all of the solder off of the board. So it just leaves behind an amount of solder that's stuck there by surface tension and won't want to come off. I think the gold plating ends up producing a much cleaner look. Plus it's gold, which is pretty cool. And it's lead free, I think. I'm going to have to come up with a way to function test these to make sure that all of the connectors work. So I need to plug them into a 3D printer or a 3D printer analog. That'll just go through a basic test and verify that everything's working. Because Mr. Clicky only detects shorts, it won't detect open circuits. So if I were making a 3D printer, I would probably want to focus on the things that I think are important for 3D printers. Mainly ease of modability, really clean, simple wiring. I like ribbon cables, like the kind that's used on the artillery sidewinder, but I'm not sure if that's the best solution because they are kind of fragile. I think they're great in applications where the cable is completely enclosed and nothing can bump into it. But even on my artillery sidewinder, I had it sitting on the floor and I accidentally kicked it and unplugged one of the cables, which I guess would be bad for any 3D printer, but it's kind of like this loop of wire that's hanging out. I'd rather it be completely enclosed. Like if you look in a regular paper printer, like an inkjet printer, they use those type of ribbon cables, but it's completely enclosed. There's no way you can touch them. Same with like laptops. It's pretty common to have the screen connections go through a ribbon cable like that, but it's completely enclosed so you can't touch it. That should be kind of a rule when you're working with that kind of connector. Set up a board with custom firmware that just loops the G-code when powered on. For what? So it just prints the same thing over and over again? That would be a fun troll build. Like an April Fool's thing. So on 3D printers, there's usually 4 fans. You've got the power supply fan, the motherboard fan, the hot end heatsink fan, and the part cooling fan. I think 3 of those could be eliminated. The only fan that you actually need is the part cooling fan. And that's only on prints where you're doing overhangs or they're really small with low layer times. So I'd say for a good 20 to 40% of prints, you don't even need a part cooling fan. I've got kind of a neat design coming up for the Sprite hot end. I think I have a way to get rid of the hot end heatsink fan, but I've got to test it out and make sure it works. That's what this thing's about. Ta-da! You know what this is? Hooey. Oh, hers. Did you see the? You recognized the thing? So I think most people are aware that those are. Well, yeah, you'd have to pair it with a heat sink. So it's just a way to transfer heat. It's not a way to store. Like, you don't want to be storing heat. You're just using it to get heat out of the area. Then you have to have a cooling device, like some kind of like heatsink fins on that. That'll help dissipate it. Do you know what the working fluid is on most of those? I always thought it was something complicated. But I looked on the data sheet and I was kind of surprised. Yep, it's water. Hey, Zany boy. Yeah, so King said I'm not dissipating the heat using that. I'll just show you the half-completed device that I have. I need a better fin setup than this, but if you get enough surface area on one end, it'll be able to dissipate heat through this fast enough. No, it's not vodka. I thought it would have been some kind of refrigerant, like what they normally use for heat transfer fluids, but it's just water. So the cool thing about it is if you stick this onto your 3D printer, like you put it on the x-axis, as you're moving back and forth, it's going to be waving around in the wind and cooling off. And if you shake it this way, you're actually sloshing the water back and forth inside of the tube. So it's like moving the heat through just the physical motion of the water, in addition to the vapor stuff that goes on. I think they have some kind of, it's under a partial vacuum or something. Like, whoever's designing these probably has a good understanding of thermodynamics. I think I'm going to have to stream this manufacturing process again when I switch to the lead-free solder. There might be a little bit more swearing involved, but it's going to be important evidence for the European authorities when they call my boards into question. Alright, another one done. I'm starting to get a little pile here. Bro recently got a Prusa MK3. I think you could tell him that he got a great printer. I don't want to be mean, so I will leave it at that. They are good printers, though. The Prusas, since they use linear rails, you don't have to mess around with the tensioning the V-groove wheels. That's just kind of annoying. If there was one upgrade I would put on a Prusa, it would just be a CHT nozzle. One thing that you should watch out for is the nozzles tend to come loose over time. Chat, yep, Eskander, thanks for giving everyone the reminder. But Zany Boy, when the Prusas are operating over a long period of time, the nozzles can come loose, and it'll cause this issue that I've posted about before. I've seen it in some Prusas that I was using for my job. I had access to 2 Prusas, and one of them had this issue where the nozzle worked itself loose and then it started leaking filament. I'll put a picture of some on the screen. I think it's called Prusa Blob. Gotta make sure this is all YouTube safe here. Okay. So, Prusa Blob. It's this gigantic blob of filament that builds up from a nozzle leak. And when I complained about this, there's a bunch of people that jumped into my Reddit thread where I was talking about this, and they're like, "Well, yeah, you shouldn't have left the printer running unattended." All right, see ya, Eskander. Thanks for dropping in. They told me, no. Yeah, that this is just normal. But the issue with this is, since the whole hot end is 3D printed, this plastic will stick to that plastic, and you end up having to reprint a bunch of parts. And it's kind of complicated to take it apart and disassemble. So yeah, the trick is to just tighten the nozzle every couple of 100 hours of printing. I think that's the best way to prevent it from happening. But that's really the only issue that I know of with Prusas. And just, they also recommend that you lubricate the linear rails occasionally with some kind of grease. I think they said every 500 hours when I was talking to them. So yeah, just a couple things to look out for. But overall, they're pretty low maintenance machines thanks to the linear rails. All right, King Sid doesn't trust it. I'm going to have to do some testing. That's why we test. King Sid, I don't know if you've seen my my first video about a fanless 3D printer, but I basically took a CPU heatsink, like from an old Intel computer, and I drilled a hole in it to make it into a hot end. And it worked. Just due to there being a massive heatsink with a ton of cooling fins. So what I would want to do with this, one of these, is wrap it in enough fins so that it dissipates the heat. It's totally doable. And it's basically water cooling without any kind of pump involved. And there's basically zero risk of spilling water on anything. You don't have to have all those coolant tubes, the radiator. I mean, you have to have a radiator, but it's all built into the one thing. Oh, you had the blob on your Ender 3? Yeah, it can happen to any printer. I was just annoyed that it happened on my Prusa because I bought I mean it wasn't my personal printer. I bought it with the company money. But we bought it pre-assembled. So it must have been put together correctly. I'm assuming it was put together correctly, but there is that issue that basically wasn't told to us. There was no mention that you should be retightening things occasionally. But after the fact, after I had an issue with it, that's what support suggested. So a little preventative maintenance can go a long way to helping you out there. Oh, and the other thing that bothered me is that they didn't provide any replacement parts because some of the components were damaged by the blob and had to be replaced. But it wasn't covered under warranty. Alright, I'm getting pretty good at this. Oh, okay. Thought I was doing it backwards for a second. No, I'm worried. I'm worried that I did a bunch of them backwards. Oh man, these are such a pain to remove a 24-pin connector like this. So I really hope I didn't do any of them backwards. Hopefully you guys are paying attention and will stop me if I'm going to do that. I'm talking of heat pipes for exactly 2 months. That's why I like it so much you're investigating. Yep. I don't even know what I'm looking at when I'm looking at the screen. Good luck. Nathan, you're going to be proud of me for this. I'm trying to start a 3D printing makerspace at my school. And the first one we got was Voxel Abakila. Cool. Whereabout are you, zany boy? I might be able to send you some half-broken printers. I'm on the East Coast. But yeah, I've been telling everyone I need to find a way to get rid of some of my printers. Because I have like 15 or 16 of them now. I wouldn't be opposed to donating them for a school or something. It's just a matter of like finding a good program that would actually put them to use. Oh, okay. Yeah, I know someone else in New York that wanted one of my printers. New York's pretty fun. You want half broken enders? Well, I got plenty of those. So, you're in luck. But yeah, Zany Boy, if you have like a sponsor, like I don't know, if you have like a kind of like a teacher that's helping you out with this stuff, if you have them email me, I can see what I can set up for sending you guys a printer or two. But yeah, I think it's great to get involved with all this technology stuff when you're in school, because it's a great time to learn. A lot of the things that I think a lot of people don't know how to do, they could have easily learned in high school or college when they had the time. But once you get older, you get a job and all these responsibilities, it's hard to pick up new skills because you don't really have the time to work on it. But yeah, like CAD modeling, I did a lot of like wood shop and metal shop and ceramics work when I was in high school. And that's definitely helped shape the kind of skills that I have today. I didn't do any electronics when I was in high school though. But I got into that in college. Oh yeah. Well, don't worry, they work. I mean, I'm just the printers work. They're just not 100% stock. So a lot of them have like upgraded hot ends and extruders and stuff. Um, it's exactly the same to use the printers. They're just you won't find any information about the parts in a user manual or something. Donate some printers to my Lego farm. Yeah. They're not Legos. They're Lego compatible. What do you call them? Lego compatible components. Nice. I've uh, I've taught some classes for like um, young kids, like first grade and third grade and stuff. And I don't know what I was expecting, but they weren't as smart as I thought they'd be. I mean, I'm sure I was that way when I was that age too. But I'm like, oh, I want to teach them so much stuff, but they're just not at the point where they're ready for a whole lot of advanced concepts like college students are. Klemmbaustein. Is that a German word for the exact thing I'm describing? I've heard there's a German word for everything, especially complex emotions. Nice. Yeah, CAD's fun. It's almost like a video game. I mean, a lot of what people are doing in Minecraft is basically CAD, where they're building these mansions and stuff and mountain landscapes. All right, just one more to go, and then I'm gonna start putting the through hole connectors on. We'll get these 19 all tidied up. And I want to finish off this stream by testing all 19 of them and see what kind of pass rate I'm getting. I think one of them won't pass because when I was inspecting them, I think I saw a short. But we'll see what Mr. Clicky thinks. The Lego group wants you to call official Lego parts Lego, and therefore adding the S is free real estate. Okay. Thank you for coming to my SID talk. Oh, okay. So anything that's like Lego is Klemmbaustein. I would want to make a 3D printer that is Klemmbaustein, where you just kind of put things together and it works and all the connectors make sense. And if you want to switch a fan out, it isn't like a hours-long ordeal where you're trying to find the right connectors, buying specialty parts and all this crap. Thanks, Creality. US on the lead versions, yeah. I won't get it mixed up. I think what I'll do is I'll do a separate batch and put them in a different box, but I do need a way to mark them to make sure I don't mix them up. I'm sure they sell ROHS stickers that I could buy and just slap a little sticker on the ones that I do correctly. Yeah. Extra leaded solder and chewing gum lead. Alright. One more 24-pin header. Hey man, this leaded solder is great. You don't know what you're missing out on. I think it has better mechanical properties, like it's better at resisting temperature change and fatigue. So you could make the argument that it's more sustainable to use a better material, because you'll end up with less waste. Zany Boy, these PCBs are for Ender 3S1 upgrades. So this is a board that comes on the Ender 3S1. This one's all messed up now because I've been, let's say, playing with it. I just wanted to see how thick the copper that they used was. But basically, Creality shipped all of their printers with these really small connectors. So it's really hard to plug, like if you buy a new fan, it's really hard to plug it in. So what I'm doing is I'm creating a new system where on the top you have all of the old connectors, so it's backwards compatible. I mean, yeah, on the bottom here you have all the old connectors, so it's backwards compatible. And then on the top you have the standard connectors for fans and stuff. So you can just buy a new fan and plug it in. Otherwise, you have to solder or crimp your own connectors, and it's really annoying because these are really small and easy to make mistakes with. But these bigger ones are just easier to work with, and 90% of the time you buy a fan off of Amazon, it comes with that style of connector. So it just makes it a more plug-and-play experience. Oh, thanks, Sandy boy. What you got the Aquila for your makerspace? Do you have any other printers or equipment? Princess Emily. Okay. So you have an Ender 3S1. Have you taken it apart to the point where you can see the breakout board on it? This little piece. This one. Oosh. You posted pics of your fan duct. It's better? Yeah, we'll see about that. I'll devise a test. And if my fan doesn't win the test, I'll redevise the test until my fan wins. It's called a moving goalpost. Alright, this is my last 24-pin header of the night, and then we'll move on to the other connectors. For all of those who are new in the chat, this printer PCB is gold plated. It's gold. Look at it. It's all shiny. It's like a piece of jewelry for your 3D printer. Princess Emily deserves the best. Alright, let's take stock of what we have here. I'm going to move Mr. Clicky out of the way for now. He'll be back in just a minute. So the last thing I need to do on these 19 boards is solder these connectors on. So we see this little stockpile here. We've got the standard connectors. If I just grab a random fan out of my box of fans, you can see here's the fan, here's the type of connector that it has. And we'll be adding a bunch of these types. We'll be adding a bunch of this type of connector onto the board, so you'll just be able to plug in your new fans and get to modding your printer instead of having to mess around with all these different wires. Alright, so yeah, I'm going to need a bunch of these. I'm going to need some of these too. And I was debating not including the this stepper motor pin header, just because most of you will probably be installing this on an Ender 3S1 with the stock hot end. what do you call it, the sprite hot end. But I figure I'll just solder this on just for completeness. That way if you do decide to switch to like some other type of extruder, you've got the more standard type of connector for it. So let's begin the soldering. This part should be a little bit faster. Gosh. It's a minor setback. I'm going to catch up on the chat here. I use leaded solder on things too. Just commercial products can't contain the usual. Okay, interesting. Might give it a try. Standard automotive practice. You have an Ender 3 V2 that you kind of hate, have an Ender 3 S1 and Ender 3 Pro. I bought because of the Micro Center deal. Yeah, that's true. Micro Center tends to put those Ender 3 Pros on sale for pretty good prices. I think I saw one for $99, if I'm not mistaken, which is a pretty sweet deal. I'll be working on a similar breakout board for the Ender 3 Pro, like that older style of printer. So that might be something that'll make it a little more fun to work with. One of the things I don't like about the older style Ender 3s is when you modify anything, let's say you put a new fan on, you have to run the entire length of the cable back through the wiring harness, and it's kind of annoying. So by adding some kind of breakout board similar to this, I think it'd make working on those printers a lot more fun. All right. Too many connectors. Curse the people that asked for backwards compatibility. It makes these things take like twice as long to build. But you know what? I think if we're talking about an optimal experience, I think you get the optimal experience by having the backwards compatibility. So can anyone guess the resolution of my webcam? I'm curious if you can tell what resolution it is. Alright, learning to code. I haven't actually printed anything lately because of schoolwork and been coding. Yeah, coding is great. That'll open up a lot of opportunities. I've done some programming for I'm mostly a mechanical engineer and do some electrical work. And coding has been really useful for doing a lot of different things at work. Plus, it's just kind of fun. It's a little more like logical than design. Like when you design something like this, half the decisions aren't really logical decisions. It's just a matter of doing something. You can rationalize your design choices, but at the end of the day, there isn't really like a logical, like this has to be here or this has to be a certain way. So there's a lot of flexibility, which kind of makes it fun. But when you get into code, there's a lot of rigid rules that you have to do things. You have to word things exactly a specific way. But then again, there is room for creativity in how you solve problems there too. I've got some projects coming up that I'll be posting on the channel that involve some coding. So you might find those entertaining. I use Python for most of my stuff, and occasionally I'll do C++. At least the type of programming that I'll do is C++ that's specifically for programming Arduinos. So my little test device is running a loop in C++, where it's basically just turning each relay on one at a time. And we'll be taking a look at that machine in about 20 minutes once I've finished soldering some of these together. Alright, that looks good. Will you get a box for the different stages already? You make the German uneasy with those piles. I use a pile system for pretty much everything. I won't let you look at my floor because you literally wouldn't be able to see my floor. There's piles all over the place. So it's not a matter of me not wanting to show you. It's just you physically can't see it. So yeah, it's a little inefficient. I worked for a German company at one point, and they weren't a big fan of my general work practices. I think it's kind of a cultural difference. You guys have too many rules. 320p, 360p, ouch, King. That hurts. But you're not too far off. It's 720p. I should, I need to use a different computer or something to upscale it to what this camera can actually do. It can do 4K. But I think 1080 would be enough. I mean, this is just a live stream. I don't want to have, like, connection issues. But I'll try out using a higher bitrate, higher resolution video next time. I could really stand to use some fixtures here. Like if I had some 3D printed stuff that just helped me line everything up perfectly for this, that would really speed things up. If only I knew someone that could use a 3D printer. Okay. So the setup took a while, but here's the payoff. Everything's all ready for me to solder. So, how's the video quality showing up? Does it look pretty clear? Because on my screen I can see it pretty well, but let's see. I mean, it's not the best looking quality on the stream that I'm checking. But I think that's just part of the deal when you're streaming. They downsample the video quite a bit. So yeah, that's what we're stuck with. Next time I'll try streaming in 4K and see if it allocates a little bit more bandwidth to me. Video's fine? Good. Alright, I'll check out Discord, probably after this, just because I got a lot of stuff to focus on here already. Boom, that was easy. SWX2, yeah, Sidewinder X2 is nice. S1 has dual feed gears and a huge community. Yeah, that's true. One upgrade combination that I think would be really interesting for the Sidewinder is the Bondtech LGX on the Sidewinder. Apparently a lot of people have done that upgrade, and that could be a really nice combination. Because in my review I thought that the only point of the Sidewinder that could use improvement was the extruder. It not having a dual gear direct drive extruder I think is kind of an oversight on a printer like that. But you get one of the best dual gear direct drive extruders on the market when you get the LGX. The only issue that is that it costs about let's see. It costs about $200 for the LGX. So you're adding quite a bit of extra cost to the equation. I don't know if there's other extruders that you can throw on there. You've heard the engineering design matrix is a good way to logically design things as an engineer. Yeah, that's true, but it's all of the decisions that you make based on the matrix are based on their qualitative assessments. I mean, they can be quantitative, like you can be like, it has, this PCB has 10 ports, so it's better than the one that has 5 ports. But it's very subjective in the way that you weight things. And you can come to different conclusions based on what you value more. And it'll be different for each person that's doing a design project. Like, for instance, Creality, well, I won't go with Creality. I'll just say that when I design something, I have a certain set of values that I think are very important. Like reliability, serviceability, quality. So I'm guided to a certain solution that other people might not think is the best solution. And neither of us is right or wrong. I think I'm right. They probably think they're right. So at the end of the day, it's just kind of like it's kind of like an art, where you just have to be good at weighing different design choices and understanding what your target market wants. I'm a big fan of functional block diagrams. I think it's a great way to look at design. So that's something that was really heavily pushed at the school that I went to for engineering. And at first I was like, yeah, okay. You're just trying to structure this, I get it. But it teaches you to frame things in a way that you don't care what the solution is. All you care about is what it does for you. So it lets you abstract the idea of like something that grinds up something. Like you don't care if it's a ceramic burr grinder, or if it's like a steel toothed spinning blade or whatever. All you care about is the function of the mechanism, like what it does for you, which I think is a really powerful way to look at things. That's some of what leads me to the solutions that I choose in terms of, like when I design a printer and I want it to be as quiet as possible. you're basically just trying to cool something down. And whether you do that with a fan or with convective passive cooling or with radiative cooling or with fluid transfer, it doesn't matter what the solution is as long as it cools the thing down. So it kind of makes you think about things in terms of function rather than in terms of specific solutions, which can get you pigeonholed into designing things a certain way that might not be the best way. I know that nobody doesn't tune it to get what they settled on beforehand. I myself catch my time every time doing that. What do you mean for tuning? Piles, but block diagrams, state machines. State machines are an amazing way to iterate through a process of logic and design mainly for programming, but it's a really modular system. I'm not familiar with state machines. Can you do like a 1 or 2 sentence example of what a state machine is and how you could use it? I've heard of the concept before, and like that it's mostly used in computer science as far as I know. Oh, okay, the design matrix, yeah. Yeah, there's no right answer. That's the hard part of engineering sometimes. There's no single right answer. I've spent a lot of time trying to seek out the perfect solution to many problems. So I went to I studied design optimization. So the computer will design something for you that's supposed to be the optimal solution. That's the best design, that nobody can make a better design than the computer makes. But the issue with that is it all comes down to initial conditions and how you phrase the problem. If you don't phrase the problem perfectly, then the solution that you get will be, even if it's perfect for that, the problem that you gave to the computer, it's not going to be the best solution for the real world. I think Elon Musk is a fan of this kind of idea because there's a book, 2001: A Space Odyssey, and I think they said something like the meaning of life, the answer to the question of the meaning of life is how to phrase the question or something, like the how you phrase the question is more important than the answer. I don't know if it was 2001: A Space Odyssey or what book that was from, but maybe it was Hitchhiker's Guide to the Galaxy. The answer to the meaning of life is 42, but what is the question of the meaning of life? I don't know. So a state machine is a block diagram that uses transitional if statements. So if this, then that kind of stuff. Maybe I should do these one at a time. Trying to make my life easier here. Hitchhiker's Guide. Okay, yeah. I listen to both of those on audiobook around the same time, so I get them kind of mixed up sometimes. They're both good books. I would shill for Audible. Maybe I should. It's a really good service if you want to listen to some classic books while you're driving or whatever. So one of the ideas I have for a skit is how many towels does a man need? That's it. Oh, 42. But anyways, one of the skits that I wanted to, I've kind of written a little bit of a script for, is, you know how everyone talks about the 3D printing community as if it's this one thing? Everyone agrees that there's a 3D printing community and there's people who are part of it. I was thinking of making a place called the 3D Printing Community Center, like what they have in the middle of some towns that do like social events and stuff. And part of this 3D printing community center is they're having these meetings. So, you know, they have like a couple of different support groups. One of them is the Creality Users Support Group. Because normally when you have a support group, it's because something bad has happened to you. But if you look at owning a Creality printer, you need a support group because it's like something bad happened to you. Alright, so Zany Boy, if switch equals on, go to state light on. Alright, pretty simple. So I would argue that for a design process, a design doesn't necessarily have a state. It doesn't alternate between states. The design is a fixed document of how the thing is supposed to work or how it's built. Now, if you look at a design that has to do things, then you could use a functional state you could use a state machine to represent different states of that design. But like this PCB, if we look at the design of this PCB, it's always the same. Even if you plug different things into it, the actual layout of pins and stuff doesn't change. It might be useful for like a living design project where you're always changing what the design looks like. Maybe like for a house, there's like gonna be a best way to design a house for a specific region or like a different state of the market. I don't know. Maybe I'm just trying to think. I'm just kind of thinking out loud. Yeah. I think an instance of a design can have a state, but the actual, like if you wrote a book about this PCB, you could describe it without having a state. Like it's, once it's built, it's supposed to be like this. Oh yeah, here's a way that a state diagram could be useful in designing. Yeah, for something that's like constantly changing. So like an example would be like one of those aerial refueling tankers that the military uses. It's got a couple of different states. It can be like on a mission or on standby, and you'd want to model it accurately for all those different situations that it'll be in. Hooey. Oh. I'm getting prank called. All right, so let's see how many we've finished. We've got we've got 5 here. Not quite the 100 I was going for. I'm gonna finish these 5 off, and then we'll test them, and we'll call it a night. All right, yeah. See ya, King. Anything that can internalize feedback could use a state machine. Yeah, that's good. So yeah, let's finish these last 5 up, and then I gotta catch some Z's. I could really use some of that pizza that what's his face got at the beginning of this stream. Alright, I gotta turbo these things out. It's getting late. I think I'm gonna get most of these done over the weekend. Oh yeah, definitely. So Zany Boy, just send whoever's, I don't know. It's usually better to work with an adult on these things. I know you're plenty mature enough to handle the 3D printer handoff and stuff, but it'll be easier if they just give me an address to send something to, or we can figure that out. All right. These ones take a little bit longer to solder because there's so much copper leading to those points. It wicks away the heat. All right, those are all done. All right, yeah, Zany Boy, just send that over. Do you have access to the contact form on my website? Video showcasing the boards. What do you mean by that, Ray? I've got these, you can see them now. Like when they're finished? Or like a full video instead of a live stream? Yeah, I'll probably be making a video about these, like a dedicated video showing it doing something. Because right now it's just me putting them together. I did a print test with my prototype, which is how I made these things. And that was on, I forget which video. But I installed it onto my Ender 3S1 Pro, no, my Ender 3S1 original edition. And I printed a couple of things out. But yeah, I definitely want to make a video specifically about the board and like the kind of mods it allows you to do. And I'll kind of cover the difference of what the experience is like to change out your fans on the stock board versus with this board. I think, yeah, that'll kind of showcase why you might want to get something like this. All right. Last one. All right, our goal was 100 boards tonight, and I got 5. And I've got 14 half-completed boards. So that's not too bad. I still have to error check these and make sure that they're working. I think a couple of them might have some shorts that I need to fix, but overall, it's not too much worse than what I was expecting. Route School of Director of Tech. Alright, sounds good. Sounds very official. Alright, here's 5 completed boards. Time to bust out Mr. Clicky. He will tell us how good we did. If I did a good job or not. So those of you who aren't familiar, Mr. Clicky is my Director of Test Operations, who's kind of in charge of my quality control here. So here we go. I'm just going to rapid fire test all these. And then I got to go to bed, so I'll be logging off for the stream after this. Alright, where is it? Now let's see how we did. So here's Mr. Clicky. He goes clickety click. So the deal is, if you haven't seen the video that explains how this machine works, basically I plug one of the boards into this machine, and then it lights up these relays one at a time, and basically if there's no shorts, then these lights will just line up one at a time. If there's any shorts or errors on these boards, multiples of the lights will light up at any given time. So that's what we're trying to avoid, and I'm going to test every single one of the boards that I make sure that they're all of good quality. So, nothing plugged in. Mr. Clicky just goes through one light at a time. If I plug this in, we're all plugged in. Let me change my exposure settings. I'm going to have to dim things down a little bit here because these lights are bright. But as you can see, we've got one light at a time flipping on, which means that there's no abnormal shorts detected on this board. So, quality control on this one, pass. Next board, we're going to plug it in and see what Mr. Clicky thinks. Oh, we got one short here. So, I'll see if I can spot it. If I look closely here, I can kind of see in here there's a little bit of extra solder. So if I can just melt that away, I think I can address that short. I'm gonna need some solder wick. Where are you, solder wick? There we go. So this is the cool thing about testing, is you can pinpoint where you have issues and you can fix them. And as you can see, we no longer have an issue with the short. Oh, no, we do. We still have it. Didn't fix it yet. So I'm gonna wet that area with solder. And then soak it up. Okay. Come on, solder wick, do your thing. Okay, that should have done it. There we go. We addressed that short. So that's the beauty of testing. Now if we look back over here, one at a time, no duplicates. That's good. Alright, so this one passes quality control now. Next board. Alright, this one's got a short too. We gotta fix it. Nope, actually there's no shorts. I don't know why that was... I must have been mistaken. Alright, this one passes quality control. Next board. This one also passes. Woo! We're on the home stretch. We'll do a full run. No duplicates. That means no shorts. Alright, and the last one of the day. Will it pass? Oh, we got the same issue. So it's on that same part of the board right here on the stepper motors. So, same problem. Calls for the same solution. And pinpointing these issues and fixing them gives me a good idea of where I need to improve my processes. So to avoid these kind of issues in the future, I think I need to be a little more tidy in how I apply the solder paste in that area. So soak that solder up. Alright, now we got them all passing. That's a good thing. And last thing I'll do is we'll do our, I call this the shunt board because all of them have been shorted together back here. So when I plug it in, all of the lights should flip on for every iteration. And that just verifies that there's nothing wrong with the connector that I'm using. Yep, that's good. The last one blinks on because it's not actually assigned to anything. There's only 15 pin groups on this PCB, so there we go. Alrighty. So that's the end of my first live stream. It was pretty fun. I'm going to be building a lot more of these boards, so I'll probably be doing some more of these live streams, Q&As, and all that kind of stuff. So thanks for joining. I'll see you in the next video, and we'll be cranking out at least 100 of these boards someday. See you in the next video.